Prime and composite numbers. Page 60. You will find out that in most cases, not necessarily all cases, but in most cases, you have whole numbers that are either going to be known as prime numbers or composite numbers. And it all has to do with the number of factors they have. What are factors? Say. The numbers in the multiplication problem. Factors are what are being multiplied. So for example, give me a multiplication example problem. Mariah. Can we do 5 times something else besides its own number? 3, 2, whatever. And that would equal 15. Your factors are 5 and 3. 15 is your product. Okay? So you might say that 2 factors of 15 are what? What are 2 factors of 15 based on the example on the board, Carlos? Yeah, 3 and 5. Because I can use those numbers to get 15 if I want to multiply them together. Okay? Now, 15 would also be known as a composite number. And I can tell that right away. Why is it?
Because it's more than 2 numbers that equals 15.
Usually, or all the time, for prime numbers, they only have 2 factors. And those 2 factors are what? Yes. 1 and 1 and itself. The only way I can get that number through multiplication is by multiplying that number times 1. There are no other factor combinations that I can use. So do you have an example of a prime number? Desriana. Let's not use 1. 13. So if I were to think of the number 13, and now we're going to try to list all the possible factors of 13. Well, the first one I would list would be 1 times 13. Now, there's a reason why yesterday we did all those divisibility rules, because I can put these numbers to the test. Is 13 divisible by 2? Is it even? No. The sum of the digits, 1 plus 3, is 4. Is that divisible by 3? 4? No, it's not divisible by 3. Is 14 divisible by, or 13 divisible by 4? No. Is this a 5 or a 0?
No.
Was it divisible by 2 and 3? So it's not divisible by 6. How about 9? Is 4 divisible by 9? No. Does it end in a 0? No. So, therefore, I wasn't able to find any other matches. Therefore, 13 would be a prime number. Okay? Now let's explore 15. You always start with 1 and itself. Is 15 divisible by 2? No. It's not even. Is it divisible by 3? And we saw that earlier. Is there anything else besides 5? If I do 5, it's 5 times 3. I still have the 3 and the 5. Okay? Is there anything else I can use for whole numbers that are going to be factors of 15? Say? you still have 5 and 3. It's just in a different order. Okay? So then if I were to go ahead and list these factors, if you're asked to list the factors, go least to greatest. 1, 3, 5, 15 are all the factors of 15. Now some have more than 4, some have 8, some have, there's some that have a lot. There's some that just have 1 in itself. But the difference between prime and composite is simply that. Now, do prime numbers have a certain look? Does a number just look prime? Well, I'm going to give you 2 to try on your own. I want you to do this. I want you to list what they have, and then I want you to put them in order. Okay, can you handle that? All right. 48 and 57. Okay, let's run them through the tests. 1 and 48. That's a lock. You put that one down first every time. Is 48 divisible by 2? Yes. So it's 2 times what? Is 48 divisible by 3? What's 4 plus 8? 12. Is 12 divisible by 3? Yeah. 3 times. Well, what do you do if you don't know? You got to figure it out. For real. 3 times 16. Is 48 divisible by 4? 4 times 12. Is it divisible by 5? No. How about 6? Was it divisible by 2 and 3? 6 times 8. How about 7? That's the only number left. Nope. So I'm going to list them in order. 1. And I just go this way. 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. List them in order from least to greatest. I find out what they are. And I start with the 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. Just kind of go around. Okay? And if you pay attention, it makes a nice big smile. Because it makes you so happy. How about 57? What do we got for 57? What do we got for 57? Well, we got this one right away. Prime? No! No! If you say it's prime, you did not go through your steps. You just got done telling me that prime numbers don't have a certain look. 57 looks prime, but it isn't. It's not even. Tell me the sum of the digits, please. 5 plus 7 is what, Desriana? 12. Is 12 divisible by 3? Then so is 57. What do? You have to find out if you don't know. 1, 27. 9, 3 times 19. List them. 1, 3, 19, 57. Do not assume a number is prime unless you run it through your tests. Yes, ma'am.
You always have to do 1 time.
Yes, you always have to do the first one. Always, always, always. Yep, that's the first one you do. Okay? See? Happy. 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 Can we, maybe to help ourselves out a little bit, trying to come up with the prime numbers from 1 to 40? We can go ahead and put 1 down. How about 2? Is 2 prime? Carlos. What else besides 1 times 2 gives you 2? Anything else besides 1 times 2 it gives you 2? 2 times 1 are the same numbers, same factors, my friend. 2 prime. How about 3? How about 4?
No.
From here on out, any even number is not going to be prime. So always be divisible by 2. How about 5? We'll skip 6 because it's even. How about 7? How about 9? No, because of 3. 3 times 3. How about 11? 13? 15? No, good. 17? 19? 21? Because of 3 times 7, right? 23? 25? 27? 29? 31? 33? 35? 33, 3 times 11. 37? 39? No, because 3 plus 9 is 12. 12 is divisible by 3. There they are. Get them down somewhere in your notes. Here's what you need to have for number 1. Number 1 is 15. So maybe somewhere on a separate sheet, you need to do this. You need to say, okay, 1 times 15. I know the other one is 3 times 5. I'm pretty positive that's it because I know we just did this one in class and I have it in my notes. When they want you to list the factors, I want you to list them in order from least to greatest. So start with the 1, 3, 5, 15. 15 is not divisible by 2. That makes it divisible by 3, not 2. If it's even, if it ends in a 0, 2, 4, 6, or 8, then it's divisible by 2. It ends in a 5. Okay? That's it. 13 lists the prime numbers that are less than 20. If you copy that list that we just had up on the board, you've got them right there. You've got all the prime numbers that are less than 20 if you identify the prime numbers less than 20. So no sweat. Those of you doing the redo, backside, 3-1. You'll have numbers 1 through 12. And these are simply yes or no. Determine whether the first number listed is divisible by the second. Okay?
Can you like do this like even over and say, can you do it now still?
Like I said, you could, maybe you missed that part. Maybe you were.
No, I know you said you can say redo, but like.
You can always redo, and it can always improve your grade. Okay? Unless you had 100%, that's not really going to help you much.